Good morning. We've talked about percent composition and how you can find the percent of carbon in a substance or hydrogen. And if you've ever watched any of the crime shows, that is what they do when they put a soil sample in and determine different percents of soil, or if they have gunshot residue or bomb residue. That's how they can figure out what chemicals are in a compound, by looking at the percents. But some compounds have the same percent composition but different formulas. For that, what that comes from is what we call the empirical formula. All right, if this is the formula for glucose, C6H12O6, that percent composition is the same as this guy, which is formaldehyde. Okay, in fact, if you look, glucose is 6 times larger than formaldehyde. So if you know a percent composition, you can calculate what we call the empirical formula. And the empirical formula will give us that smallest percentage composition, or not percent composition. You use the percent composition to find that smallest ratio. So how can you calculate the empirical formula? The subscripts in the formula give the lowest whole number ratio for atoms or moles of elements in the compound. So once again, up here, C6H12O6, this is a 1 to 2 to 1 ratio, which is what formaldehyde's formula is. So if you plug those in and calculate percent composition, they're going to come out to be the same thing. All right, an empirical formula may be the same as a molecular formula in the case of formaldehyde, or it could be a simplified version of a more complex molecule, as in the case of glucose. CH2O is the empirical formula for both glucose and formaldehyde. Okay, if you have an ionic compound like sodium chloride, it always is the empirical formula. Ionic compounds always have their empirical formula, but molecular compounds sometimes do not. So we have to be able to figure out what the empirical formula is, and then we have a way to figure out what the molecular formula is. Okay, H2O2, the lowest ratio would be HO. It's a 1-to-1 ratio. The percent composition of a compound can be used to calculate the empirical formula. The percent composition tells the ratio of masses. The ratio of masses can be changed to ratio of moles by changing grams to moles. Okay, so here we have, and then the mole ratio is then reduced to the lowest whole number ratio. Here we have a compound is analyzed, and we have 25% nitrogen and 74% oxygen. Nitrogen, 25.9%, and oxygen, 74.1%. Now, the process can be summed up in a poem, which I somehow did not include in the typed part, but you're going to write down here at the bottom. The first line is percent to mass. So you change in a percent composition, change percent to mass. Then you change mass to moles. Then you divide by the smallest moles to get a 1 to something ratio, and then you multiply until the number is whole. Okay? Percent to mass, mass to moles, divide by small, multiply till whole. Okay? So in this first one, we're given percents. So we need to change those percents to mass. Now watch carefully. This is very, very difficult process. Are you watching? Change percent to mass. Now, the next step, I'm going to use a different color for the next step. Mass to moles. How do I change grams to moles? Look at your mole map. If you said divide by molar mass, I'm going to divide by the molar mass. I'm not going to use rail fence here simply because I don't have enough room. And then I need a calculator. And of course, the one I had out last night, the gremlins have stolen. Here we go. 25.9 divided by 14.01 gives us 1.84 moles. Actually 1.85. Try and keep it to about 3 significant figures, just because the more you have, the closer it's going to be. 74.1 divided by 15.999 gives us 4.63. So, percent to mass. Now mass, damn it. I'm going to change that to red so it matches. And now I'm going to use a new color. I'm going to use green. Oh, I don't want to do that until I okay. And I move the whole page. Fun with Mrs. Bush and technology. Okay, so the next line in the poem is divide by small. So we're going to divide by the smaller of these two, which is 1.85. If I divide 1.85 by 1.85, I get 1, right? So I'm going to have a 1 to something ratio. 4.63 divided by 1.85. Okay, so that now change that to green. And for some reason it didn't change all of them to green. I'm not going to worry about it at the moment though. The final line in the poem says to multiply until whole. Now sometimes if you get two whole numbers you don't have to worry about this. But here we have 1 and we have 2.5. What can I multiply 2.5 by to get a whole number? Well, 2 halves is the same as saying I have 5 halves, right? If I have 5 halves and I multiply it by 2, I end up with 5. So that's what we're going to do. We're going to multiply both of these by 2. So we get a 2 to 5 ratio. N2O5. All right. And that's how you do empirical formula. Okay, let's do the next one. Well, the next one talks about molecular formula. If you want to find molecular formula, when you put that substance you're analyzing into the mass spectrometer, and it comes out and tells you the percent composition, it's also going to tell you how heavy the molecule is. Okay, so that's the next step. So if we are starting with the empirical formula for glucose, we know that the molecule weighs 150 180 grams per mole, because that's one of the ones I have memorized. How many times bigger is this than the empirical formula here? If we look at the mass of the empirical formula, carbon plus 2 hydrogens is 14, plus oxygen is 16, so that adds up to 30. So the question is, how many times bigger is 180 than 30? Well, it's 6 times larger. What that means, I'm going to take C6, H2 times 6 is 12, O6. So what you have to do with the molecular formula is you need to know the mass of the compound and then the mass of the empirical formula, and you divide the empirical formula into the molecular formula. Now, the easiest way to do this is going to be to do some problems together so that you can see. Here, I did include this data table. These 3 molecules all are CH for their empirical formula. Ethine is C2H2, benzene is C6H6. So the mass of, the empirical mass of CH4 is 13, 12 plus 1. C2H2 is 26, which is 2 times 13. C6H6 is 78, which is 6 times 13. Okay. Formaldehyde, which we just talked about, has a molar mass of 30. Ethanoic acid has a molar mass of 60. And glucose has a molar mass of 80. But all 3 of these have the same empirical formula. So once again, you take the molecular mass divided by the empirical mass, and that will give you how many times you have to multiply your empirical formula by. Okay? And this describes how to do that. So let's do a practice. You've got the packet that was passed out that has the percent composition in it that you practiced. So let's start out. We've got 75.2% carbon, and hydrogen is 24.8%. What's the first step in the poem? Just yell it out. That's right. We're going to change percent to mass. What's the next step? Mass to mole. So we're going to divide carbon's mass by 12.01 and hydrogen's mass by 1.01. You all should be working this on your paper with a calculator at the same time. 75.2 divided by 12.01, 0.0027. That's not right. 75.2 divided by 12.01 is 6.26 moles. .8 divided by 1.01 is 24.6 moles. What's the next step in my poem? Percent to mass, mass to moles, divide by, if you said small, you are correct. So the smaller of these is 6.26. So we get 1, and 24.6 divided by 6.26 is 3.9, which we'll round to 4. Multiply till whole, they're both whole numbers, so we don't have to do that. So we get a chemical formula of CH4, which is methane gas. An empirical formula. Okay? The next one, sodium, chromium, and oxygen, once again, our first step. If you get confused, ask your neighbor, because hopefully they're paying attention. Change it to grams. The next step, change to moles. Sodium is 22.99. Chromium I have to look up. 51.9961. And oxygen's 15.999. Okay, 17.6 divided by 22.99 gives us 0.76. 6 moles. 39.7 divided by 51.9961 gives us 0.764 moles. And 42.7 divided by 15.999, 2.67 moles. What's the next step in the poem? The next step in the poem is divide by small, which is going to be 0.764. That's going to be 1, that's going to be 1. And this comes out to be 3.5. Now we have to use that last line of the poem, multiply, tell whole. If I multiply them all by 2, I should end up with a whole number. What color shall we use? Do orange. So I'm going to multiply that by 2, that by 2, 3.5 by 2 is 7. So in the end, I get Na2Cr2O7 as my empirical formula. Okay? This guy is not in percent compositions. This guy is in grams. So we don't have to change anything for that first step. So we're just going to write 13.5 grams of calcium. Oxygen is 10.8 grams, and hydrogen is 0.0675 grams. First step, divide by, change to moles. Calcium 40.078, oxygen 15.999, hydrogen 1.01. Alright, I made a mistake. So I had to go back and start over, or not restart over, but all right. So I've done the moles. This is, we have 0.3369 moles of calcium, 0.675 moles of oxygen, and 0.668 moles of hydrogen. So if we divide by the small, that ends up as 1. This ends up as 2, and this ends up as 2. So you could also write it out this way. I would accept that because you don't necessarily know. All right. Next guy, 8.20 grams of magnesium, 5.40 grams of oxygen. Magnesium is 24.31. Oxygen is 15.999. 8.2 divided by 24.31 gives me 0.3373. 5.4 divided by 15.999 gives me 0.3375. If I divide by the small, which is 0.3375, I end up with a 1-to-1, so that guy's formula is MgO. Okay? Last but not least, lead is 1.3813, hydrogen 0.00672, arsenic 0.4995, oxygen 0.4267. Now you're going to get ridiculously small moles here, okay? You need to try to keep 3 sig figs in them, just because if you just round to the very first one, which may be 2 or 3 zeros in, it's going to get messy. All right? So first we're going to take lead. Lead's molar mass is 207.2. Hydrogen is 1.01. Arsenic, 74.92. These are all divided signs. And oxygen, 15.999. I'll change color since I forgot to last time. So 1.3813 divided by 207.2, 0.00667. 00672 divided by 1.01, 0.00665, 0.4995 divided by 74.92, 0.00667, and 0.4267 divided by 15.999, 0.0267. Okay, these are obviously the smallest ones, so we're going to divide them all by 0.00677. And we get 3.9, and we'll round that to 4. So this guy's chemical form or empirical formula is PbHRAsO4. Okay. What I would like you to do for homework is questions 1 and 2.